So, welcome. It is my pleasure to introduce to you Dame Wendy Hole. She's a Regius Professor of Computer Science at the University of Southampton. And we are going to have a nice fireside chat with her today. In order to facilitate a more interactive fireside chat, I would also like to ask the audience to participate in this. And as a first part, I would like you to participate in the introduction while I say a few more words about Wendy. So you will see now on the shared screen a website for Mentimeter. And on this website, you will be able to vote or actually enter where you're currently in. You can either do this by going on any device you like to the website www.menti.com and use the code that is shown here, which is for the first round of questionnaires 4700182. Or you can click on the link that will appear in the chat right now. So just click on the link, will also bring you to this slide. And you will see that while we are talking, hopefully the cloud will change its shape and more participants will join. You can give in up to 3 items about where you are, saying, for example, the city, the institution, or if you are in the office or in a computer room or whatsoever. So we do hope that during the talk, this cloud will fill. And this is also some kind of warm-up exercise for you, because I will ask the audience during our talk for some more of such questions. Let me continue with the presentation of our correspondent, I may call her so, of my fireside chat partner, Wendy Hole.
I've changed my background. So I'm in the Caribbean, right? I see you've got by your fireside. I decided I'd go to the Caribbean this morning.
That's the best choice, Wendy, that you could do. We all would love to be in the Caribbean with you right now, and that's really looking great. So I had to put the fireside in my background,
Lovely.
But it's quite warming here, so it's quite nice. So wonderful. Well, actually, I think, Wendy, you have a very interesting career, because you started your career with a Bachelor of Science and a Doctor of Philosophy in Mathematics, as actually many of us did, because computer science was not that popular at the time. And I also found out that you had a very interesting title for your PhD topic. We will come back to that later on. Your career was, I may say, rocketing up pretty soon. And you did a lot of seminal work, not only from a scientific point of view, but also in pioneering females in computer science. If I'm correct, you were the first female professor which was appointed a professor position in engineering at your university in, I think, 1994. You were among the founders of the Web Science Research Initiative, WSRI, which became later the Web Science Trust. You had many, many other pioneering works. You were talking about techniques that we know nowadays as the semantic web, at times when people even didn't know what the World Wide Web was. For all those achievements, you have received numerous honors. Among them, of course, various honorary degrees from, for example, Oxford Brookes University, Glamorgan University, Cardiff University, and University of Pretoria. And there is one award that I'm really jealous of, because not many people are at least able to get it, eligible for this kind of award or honorship. You were appointed the Commander of the Order of the British Empire in 2000. And promoted to Dame Commander of the Order of British Empire in the 2009 New Year's Honors. So we may call you Dame Wendy Hole, and I hope that I still can just say Wendy. So, yeah, see, the cloud is growing. You can continue answering the questions there while we move on to the first round of questions that I would like to discuss with you. Since you were one of the pioneers in so many fields of computer science, and especially in web sciences, could you start with reflecting your perspective. If you recall the early ideas you had about multimedia information systems and hypermedia, how would be your prediction at that time about the evolution of the World Wide Web, and how would you assess what we see nowadays?
Well, there's so much in that. And of course, you know, as you, and I've been, you know, I've had a long career, and as you get to, if you have a long career, you start reflecting. And as you said, I started out as a mathematician. I moved into computing. I hated computing at university. It was Fortran and punch cards and paper tape. And I just, you know, took me a week to compute the area of a triangle. And I thought that's just, doesn't help me at all. So, and I wanted to be a pure mathematician. So, but then I couldn't get the job I wanted as a pure mathematician. There just weren't any going in universities in the 80s. And I took a job teaching teachers mathematics at a college of teacher training. And the personal computers were coming out. And one in particular was the BBC Micro. And that changed my whole opinion of computing, because it was interactive, you could do graphics, and we could even put video on the screen. It took a lot of effort in those days to write the drivers to show digital, well, it wasn't digital, it was analog video on a computer screen. There was no digital anything in those days. This is, I'm talking about the mid-80s here. We used interactive video discs, and we had to program them, and then, as I say, have the drivers on the screen. But we could do amazing things with them. We could really interact with them, and we could develop the most amazing programs to help people interact with the video and ask questions and learn. And I was fascinated by how computers would help people learn. And we now call it multimedia. In those days, it was just sound and video and text appearing on a computer screen. And, you know, I was told very firmly by one of our professors in the computing department at Southampton that there was no future for me either in computing or at Southampton if I didn't stop doing this work that wasn't computing and got back to doing programming or operating systems or compilers. Anyway, luckily the head of department supported me. And bought me a video disc. In those days, that was a lot of money, and a video disc player. Anyway, cut a long story short, I got supported to do this. And in those days, you know, today, all of the stuff I've been talking about is available on our smartphones, right, via the internet and the World Wide Web. But when I started this work, none of that existed. Even the concept of a mobile phone didn't exist. People, futurists, talked about that, and the idea of putting video on a computer in any way that was useful to people was science fiction. It was basically science fiction. And so getting grants to do the work, there were no journals, there were no conferences. And I remember asking for money to fly to Boston to go to a conference at MIT on, I think that was my first multimedia conference in sort of something like the early 90s. Or maybe the late 80s. And it had to be vetted. I had to go all the way up to the top of the department. Or could I have an airfare to go to a multimedia conference? What had that got to do with computing? It was all artists talking about, you know, and humanities students. And at that conference, I met people who were going to be the pioneers in this type of field. And I think that's where I, you know, because I stuck with it, and because I could see that these systems, when the processing power developed and when they became more interactive, and when we had a network, I could just see that it was going to change our lives. And I think I'll finish here because I could talk forever about this, but I think that I had great mentoring. I had a boss who supported me to do this, despite the fact that the papers I was writing did not rank in any sort of metric system. We were just beginning the ref in those days, and I was writing papers that were being published in embryonic multimedia journals that were more for it was like computers and history or computers and biology. You know, they weren't good computing journals. And so I wasn't, you know, they were arguing that I wasn't carrying my weight in the department because I wasn't actually writing the sorts of papers that needed to be written. And but the other thing is that I've never really enjoyed programming. I've said that a lot over my interviews in the past. I've done it and I've taught it, but it's not what I actually enjoy. What I enjoy is thinking about the future and how the things we're working on today will impact in the future. And the future means faster computers, more networks, and more capability to do these things. And I think that's my abstract. I'm a pure mathematician. I think in abstract, and I'm perfectly comfortable thinking about the technology of the future in a world that doesn't have any, how are we going to build that then, answers, and not worrying about how we're going to do it. And I think that's where I get the pioneer word. That's where I get labeled a pioneer.
Yes, I think that was a very, very nice introduction, and thank you for sharing also very personal information with
it's
us.
all going in my autobiography.
I actually found a quote that you used a couple of years ago, I think, on another event that I would like to show next. And so please, may I ask the administration to change to the next tab on the screen? Okay, thank you very much. So where there is no vision, the people perish. You use this quote, I found it on the internet in one of your talks, inspiring talks. And I think it's true to say, you mentioned you are grateful to your mentors, but you yourself are a big mentor and visionary. You were also mentioning the mispredictions of your colleagues. And actually, coming to mispredictions, I also collected some of them on the next slide. If we can move forward, please. So these are visions that people had 60 years ago up to the more recent time. And I found them interesting because we do know that they are wrong. But if you read them with a different twist, you might consider that there's actually some truth in it. So for example, the first quote, I didn't use the famous one from Watson from IBM. I used the one from Charles Darwin, who was said to have said this in 1946. One machine would suffice to solve all the problems that are demanded of it from the whole country.
That's not the Darwin, is it? There's another Darwin. It must be clearly. Anyway.
yes, it's another Darwin. But I found this quote interesting because this the Watson quote was that there is a market for something like 5 computers or so on the world. But I found this quote interesting because if you think about it, the way how we see computers nowadays, they are not single entities that are standing on our desks anymore. They do still exist there. But if you think about cloud computing and the whole network of computers, a whole fabric of computers, this quote might actually be true if you look at it from a different perspective. Or another quote, remote shopping, while entirely feasible, will flop. This was a prediction made in the Time magazine in 1966. I'm sure all of us did remote shopping. The question is, currently, we also see a trend towards more sustainable ways of shopping. People are getting more concerned. They still like to probably do remote shopping, but they also want to support now, especially in this pandemic region, their local communities. So even this might be changing a little bit, and you could shift between strongly agree and strongly disagree in this area as well. And the last one, which was a colleague from the UK, a professor at Princeton, I'm not going to disclose the name. By 2005, the internet's impact on the economy has been no greater than the fax machines. So this would be another prediction. So I'd like to ask the audience now again to use this new code to vote on this. You will also see the link while we continue our discussion on topics related to that. I would like to bring in one more dimension, one more aspect, Wendy. You mentioned when you did your seminal work in multimedia, it was the humans interacting with the media and the computers were the tools supporting the humans.
Yeah.
Nowadays, with those trends towards artificial intelligence, autonomous systems, smart technology, proactive systems, we have the feeling that we as humans give much more control to the machine. What's your opinion on this paradigm shift, I may even call it? Is this a risk? Are we able to handle it? What would be your perspectives on that?
Yeah, this is gets the heart of AI as it's considered today. I think we should remember that, I mean, you're younger than me, Gabriele, but when I was starting out in, you know, thinking about computing, even when I was doing my maths degree, what was I going to say? Where was I going with that one? Oh yeah, artificial intelligence then, which was beginning to emerge in academia, was of the philosophy department. Right, it was very much, and Turing's paper was very philosophical. I mean, he obviously, you know, he conceived it in the idea of could a machine do, but they were philosophical questions, and in a way, and you know, as I say, when I was a youngster, AI was very much about philosophy. The systems that people were building were rule based, but it was all about really, and then expert systems evolved, but it was all about could we build machines that could do what a human brain could do. Now, of course, we still have that challenge, right? There are still, of course, people thinking about that challenge, but AI itself today is really referring to machine learning and neural networks. And the reason, and again, when I was a young lecturer in the 80s, we had people working on computer vision and speech recognition and artificial intelligence as you know, in the expert systems sense, and things like, you know, automatic face recognition as a general problem was considered to be pretty much unsolvable. You know, but it was, of course, partly because in those days we didn't have the computing, we didn't have the processing power, we didn't have the data. And the people who pioneered machine learning and the neural networks, like Jeff Hinton, they were told they were idiots. It was never going to work. Right? And now, of course, our world is dominated because with these ideas and the systems that are being built based on those ideas, because we have alongside these ideas, we've developed very fast computers, as you said, cloud services, distributed services. And we have, as part of almost the rollout of the internet, we've got the ability to generate and store and analyze lots and lots and lots of data. And so machines, we are teaching machines, if you like, or they're teaching themselves, whichever way you want to think of it. They're training them to do things that we can't do with data. I mean, just like computers can do things with spreadsheets that we can't possibly do, change the world of finance beyond belief. My father was an accountant. He did everything on paper. And you know, he divided pounds, shillings and pence by pounds, shillings and pence in his head. And, you know, that world has completely gone. And but we have more jobs in the finance industry than ever before, because machines have enabled us they crunch the numbers in ways we couldn't possibly do ourselves, and give us the ability to forecast and predict things and make, you know, do amazing number crunching, so you can work out how to decide how to insure what price, you know, how to insure someone's life, or think about car insurance, or, you know, the things that the machines can enable. And then we go off and develop, the human beings develop new ideas, because the machines are crunching the numbers that feed that innovation. Now, the same thing is happening with AI, because the machines are doing amazing things like, you know, we can train an AI system to look at scans of potential tumors that could be cancerous and decide whether they're cancerous or not. They can do it faster and more accurately than human beings. But in the end, it's down to, it's a human being that's being treated, and the issue of do we allow a machine to tell a human being they've got cancer without that being checked by a medical expert or someone who has the empathy of a human being, so you've got the accuracy and the ability to interact with the human being in the way they need to be interacted with when they're getting that type of news, and thinking about courses of treatment. So, which of course the AI can help us with, because the AI will be able to, if we could get the data, we'll be able to analyze all the different, you know, who's had what treatment over what, and what were their underlying symptoms, and what was their tumor like, and the AI could deliver much more customized treatment plans. But I don't think we are not in a position at the moment where we can trust the AI systems to deal with humans, and to be certain that the results we're giving that sort of treatment are the right thing, and actually dealing with the human being. So my worry at the moment is that I talk about keeping the human in the loop, and that doesn't, humans make mistakes, so it doesn't guarantee that you're getting everything right, but it is a check and a balance against the systems making all the decisions without any moderation by human beings. And I could talk more about that, but it's this, we aren't in a position yet, and I don't think, to handle this over to the machines. And I think it's very dangerous if we did that. We've got to build it. Trust is a word I keep tripping over all the time. We have to have trust in the algorithms, trust in the data. Is something trustworthy? These are big questions for us, and we've seen it in the COVID. We've seen how, in a situation we don't understand, how data can be analyzed incorrectly and make you go down the wrong path, or maybe not incorrectly, but in a way that isn't right for the situation. Do you know what I mean?
Yes. Yeah. No, I think I fully support your point of view that AI is an important tool that can help us in processing data faster, in providing the information, in recommending certain decisions. But I fully agree with you that, for example, the cases that you mentioned, the medical treatments, etc., communication should still be among humans as much as possible, because although we try also to bring now emotions to machines, they will never have true feelings. They will never have empathy. Or
well, it depends what you mean by true feelings, right? This is where it gets back to the philosophy.
Yeah,
right?
that's true.
What does it mean for us to have true feelings? And one person's truth is another person's absolute lie. I mean, this is playing out in the vax, anti-vax at the moment, and the lockdown, anti-lockdown, and these are huge moral dilemmas. And how we can possibly expect machines to play in this world when we don't know how to. And I think that when you say machines will never be able to have emotions, it really does depend what you mean by that. Because 30 years ago we said machines wouldn't be able to detect a face in a general circumstance, and now in the general case, and now even with masks on, the Chinese algorithms can tell who you are just by, they could tell within my glasses and my fringe and a mask on, people can still tell it's me. Just by, I mean, it's just amazing what we can do.
More talking about the understanding of the machines. This is also one of the questions I had on my list. What do you think? How much understanding would machines need about our world, and how could they gain the understanding? We are pretty good in specialized cases. If we train them on a special set, yes, but the general understanding that we as human beings are, I'm still now back in the philosophy, because
well, this is the point. And I think that, it's very hard to say if and when machines will get to that sort of state. I think that if
the question, should we go in this direction?
Well, you see, this is the trouble. You're not going to stop people doing that research, are you? And it's very interesting questions, whether you treat them philosophically or you try to build a system that will take a next step, incremental step forward in terms of having emotion. I'm not going to say that in 50 years time we won't have machines that have some concept of emotion. That doesn't mean they understand it, but then you're getting into the philosophy, yes. Right? Because of course in the human world we have people who don't understand emotions, right? And people who do nasty things to other people in ways that even I can't possibly begin to understand as why we would do that. So these are very complicated questions. I think the key thing is that we can see that machines can do things that we can't do. And if we take that to the extreme, then this is what Stephen Hawking said. If we take it to the extreme, keep developing that, then Stephen Hawking's made the point. One of the last things he talked about before he died was how AI was developing. And he said, if we get to the point where machines can think like human beings, whatever that means, then that's the end of the human race, because they don't need us. We're biological. We evolve very slowly. We die. Lots of nasty, machines could take over, and I don't know what that means, right? I'm not, but it could be what would be the need for a human being? Yeah, it's a bit philosophical, but and I think the biggest problem we have is that we've outgrown our planet, and we've got to get a grip of how we use resources on the planet, or we might as well just leave it to the machines.
There are two more terms that I would like to bring into our discussion now on AI and related topics. That would be the need for research on explainable AI and the risk of bias in AI. Can you also briefly comment on those two aspects?
Explainable. What was the second one?
Bias.
Oh, bias. I thought you said fires. I'm looking at your fire. Yes, I think they're both. Well, they're very important, and in some ways, they're sort of two sides of the same coin. In other ways, they're very different. So, we are all biased, right? We as human beings are biased. And just because of the way who we are, our genetic makeup, the way we've been brought up, which culture we're in, all these things bias us to a view of the world. And when we talk and when we write, that bias is reflected. Even if you're not the most opinionated person, you still have a bias to think in the way you've been brought up and your genetic makeup. And if you train an AI system on things written in newspapers, it will be biased because those articles, are biased by the people who've written them, or the country it appears in, or what knowledge they had, or how they misinterpret or deliberately misinterpret the facts. And so in some ways, you can argue actually that machines could be less biased than us because we could train them to somehow, we could think about how we train them to get rid of that bias. But then if you start doing that, then you're creating an artificial world. So I think that in the general, this is a really difficult and gets very philosophical. What's biased and what isn't? But I think in terms of where you're actually in practicalities of where you're building a system today, then you want to get rid of obvious biases in either the data that you're using to train the system on or the algorithm that you've written. And the data, we have a problem where a lot of data sets we're using are being used are incomplete. We are going to have to develop systems where companies will say what data they are using to train their systems on, and the way to, and again with the AI we're using, it isn't possible for a deep learning system to explain how it came up with an answer at the moment. And I do worry that I'm urging our country, and I'm sure others will, to develop research programs in explainable AI. But I've got this gut feeling that this is a problem we will never be able to catch up with, because as fast as you can build a system that you can get an explanation from, someone else will be building another system that's faster and better and more complicated that you can't. And when you put quantum into this, so I think that the practical way to deal with it is to, and this is because at the moment, again, it comes back to AI is very philosophical, ethics and bias and how we justify whether, the accountability of algorithms. A lot of this is quite philosophical, and people, in ivory towers in academia like us discuss it. And actually what industry needs is practical example. How do I do this practically? How do I check it? And I think that comes down to doing some very simple things that we will develop an industry around to regulate and manage, as we have with finance. We require companies to report on their accounts, to tell what they've done with the money, to forecast their future years, and these all have to be reported and audited. And I think that we will have to develop those mechanisms for companies that are using AI to sell goods and services, develop things for other companies, And it could start with very simple checklists in terms of, you know, the audit could be, well, okay, here's tell us what your algorithm does. Now, how have you tested that? Give us some data that you've put in. What are the results, right? Just show by practical examples. This is the audit idea, that what you've done is giving the results you say it should be giving. And if we've got time, I want to just tell you a story that really was a huge scandal in the UK this year during COVID. I don't know how you did it in Austria, but this was how we predicted students' A-level grades to decide which, you know, so they could use that to say, to tell the university they got the grades they needed to get into university. And because they weren't being taught and they didn't take the exams, the government said, well, we'll create an algorithm and base it on previous results, right? And you'll get a grade. And like, to cut a long story short, what happened was that there was a huge bias in the system towards the very expensive schools because they used past data. And in past data, the state schools got worse A-level results overall than the expensive private schools. And so they'd said to the people producing the algorithm, well, you've got to mirror last year's results. It's got to look the same as last year. Now, that turned out then, and it's to be very unfair to the students in the state schools, because whatever they'd done, they couldn't match what, you know, they couldn't some of them had to get bad grades because that was to be the same as last year. So it was incredibly unfair. But it wasn't the problem, it wasn't the algorithm's fault. The algorithm did what it was designed to do. It was that the design of the system was unfair and no one had spotted it. And then they tested it on last year's, on the wrong data. And I won't go into the details. The wrong type of, you know, the wrong data sets really are looking at last year's results rather than predictions, which is what they should have been looking at. And, you know, this was a huge scandal, and it upset the government had to do a U-turn and change it to teachers' predictions and all that. And it gave algorithms a bad name, but the algorithm did what it was designed to do. Right, but the design was unfair and the way it was tested was unfair. So I think that's what we've got to test, and we will develop a whole system of audits and regulations in this world, just as we have done with finance. There's lots of jobs in this, and the governments will regulate. They will regulate this over time, but we don't know exactly what to regulate yet. So sorry, I could go on forever about that.
No, that's perfect. And I think that's also a good transition to the next topic that I would like to talk about with you. You mentioned that the algorithms in this example were built correctly, so to say, but the design was wrong. There was no appropriate audit procedure. So do we teach our students the appropriate skills when we teach them artificial intelligence?
Not yet, no, I don't think we do. And we have to develop the right syllabus. I don't think we teach our students, as you'll know, as president of the ACM, I chair, you probably don't, yes, you must know, because you're in the European Council too. I chair a group called Informatics for All, which is a coalition between the ACM and Informatics Europe and CPIS and the IFIP, looking at how we teach computing in schools in Europe. And this came from an idea, do you mind me going off on this tangent? This was CS for All in the States. That was one of the last things Obama signed off before he left the White House, which again was run by a coalition, including the ACM in the States, where they looked at the teaching of CS in US schools, and it changed the whole syllabus. Because it'd been very much, people had been teaching it in terms of what in Europe we call a term I hate, ICT, which, you know, very much about how do you use a word processor, how do you use, you know, how do you manage to build a spreadsheet, you know, how do you draw something? And what we are saying with Informatics for All, informatics, of course, being the term that's used a lot across Europe, I would call it computer science for all, but is that this is a science. I mean, this is, you know, we have to understand how the digital world works. One of the things we need to do, be able to do that is, well, how does a computer program work? It doesn't mean everyone's got to become an expert computer programmer, just like not everybody has to know how to mend a car, but you need to know about when you take it to a garage if you're being ripped off or not. And same with it. And then, you know, of course, some people will go on and become computer scientists or informatics professionals. And so we need to encourage them to go into those types of careers by thinking of these and giving them a rounded education like we do with other sciences in that area, in the area of computing generally, and that would include ethics and issues around I want to say sovereignty, that's too much, but governance of technology and policy areas for at the right appropriate level for the children in school. And we're pushing this, and then you see AI at the moment, as I said, it's now become, it came out of philosophy in a way, but it's very much a subset of maths and computer science at the moment. The sort of AI, the machine learning AI, is really coming out of our world of maths and computer science, and so we will need to include ideas about artificial intelligence and the things you're talking about there with the ethics and the auditing and the how you in the curriculum in schools as introductions, and we need to do it in such a way as that we encourage some people to specialize in these areas and go on to study them at university.
Yeah,
does that make any sense?
yeah, let's move to this next step. You said we want to motivate young people studying at the university, but on the other hand, we also know that a university career, but also a professional career in informatics, is not an easy one. It's technologically challenging. Career paths might not be as smooth, especially at the university. We are facing the problem of limited time contracts and so on and so on. But while I will then ask you the question, what kind of advice you are going to give young people who want to start such a career, I would like to do the audience also some kind of exercise in the background. So therefore, can we please move to the third tab, to the next?
Oh, perfect.
You remember the picture? We do a lot about promoting young people, and one of the initiatives also is to bring more females into computer science. And there is the conference series Women Encourage, and in 2016 it was held in Linz. And maybe, Wendy, you should be somewhere on the picture because you were giving it.
I was definitely there. I was definitely there. I'm probably in that front row somewhere.
Yeah, and I do remember this was the time when you had your broken knee and you were driving with this cool Tesla car. Do you remember?
Oh yes, I just yes, and I was using a walking stick then.
Yes, you were using a walking stick and you were driving a very fancy car. So that's what I remember.
Well, I wasn't driving. I was being driven in a Tesla. Yes. Terrifying experience.
Exactly. It was the first time that I heard I actually did not hear the car because it was completely silent. So it's
yes. Oh gosh, yes, I'd forgotten all that. Yes, of course. So the people you must understand that President Kotsis organised this conference, and we all came to Linz to see her. Yeah,
it was great. It was
in those days when we could travel.
They will come back, I hope. Maybe we can move now to the next slide, where there would be your next exercise that I would like to ask the audience. I just put in random order a couple of elements that would be important promoting a successful scientific career. And I would like to ask you in the audience to rank those, and then maybe we can come up with a picture. What I ranked here, or what I listed here, it's not a rank, it's just in random order, and you will create the link. Patents might be an indication for being successful. Many publications. Curiosity might be an important requisite. Mentors. Wendy, you mentioned mentors were very important for you. Project funds, good publications in contrast to many publications. Fortune, it might be also luck for a successful career. I'm focusing here mainly on scientific careers. The chosen thematic area, the ability to work in teams, or creativity. So please participate in this exercise as well. You should be able to change the order of the elements, and we could then see live how these elements are changing. And in the meantime, I would like to ask you, Wendy, what kind of advice would you give young people if they want to continue or start a career in informatics, either as professionals or as scientists?
Oh, look at that. That's very interesting, isn't it? The results there.
It's moving already, so it will be changing during the time. So
yeah. Oh yes, of course. But I can see it's so.
Yeah, there's already. That's good.
I think that we have to remember that we're sort of painting scientists as all the same, right? And yes, if you want to be a scientist, you have to you don't have to necessarily be a fabulous mathematician, but you have to have some, you know, mathematical literacy. You have to be able to understand. And of course, some scientists have to have a very deep understanding of mathematics. Many scientists can have quite a, you know, a sort of passing knowledge of mathematics, enough for them to be able to read papers, read articles, but in their work they won't necessarily use it. And then, of course, there's all sorts of careers around science. I mean, we've just talked about ethics and auditing for AI. You know, will auditors, are they scientists? No, I mean, they're be more like lawyers or accountants, but they may well focus on science applications. And I think that, so you can have a whole range of people who are deeply steeped into the science, and I tell you, some scientists, as you will well know, Gabriele, are not at all good at doing this sort of thing. They don't like talking to people. They like to be stuck in their books and doing their work. And getting them out of the laboratory can be quite difficult. And then there's others like you and I who love talking about what we do. And this goes across science, right? And it isn't just that women like talking and men don't. There are no patterns in this. It's to do with your personality type very much. And I think the key, I would say 2 or 3 things. One is, we talk about, you know, the students and of course their parents are hugely influential in what they do in terms of careers. But actually teachers are really important too. And if teachers have the wrong attitude about, well, girls don't do, like my headmistress who told me I couldn't go into medicine in 1969, because that was her perception of medicine in those days. And teachers who say, no, you're a girl, you don't do computing. We have to, I mean, this is our next step with Informatics for All, is to come up with guidelines for teacher trainers, actually, and for training teachers to encourage children to think about computer science at university or as informatics as a career to go into. And it's a very broad, you know, you can be at the coalface, if you like, writing code, or you can be managing a design team, right? And they're both careers in our world, and they're very different skills. And then the whole range of those, and we really need to train the teachers to be open to those ideas. And another thing, I mean, it's different in different countries, but in the UK, we really ask people to make a decision about what type of career, whether they're going to be arts or science, around 16, which is far too early. We need to encourage, even if you don't think you're very good in maths and science, to keep those doors open, because there are many degrees out there that are a mix now. Interdisciplinary degrees are emerging, where you do some science and you do it in a context that's not just science. So I can't think of examples. Computing and accountancy, or computing and the law, and there are lots of degrees. My mind's gone blank, where you can keep the science going and do it in another context that you may love. So keep the doors open, even if at 18 you decide you don't want to do science. Keep the options open, and then you don't have to have a degree in computing to end up working in the computing industry. Right.
If you say keep the options open, I think this is more than changing the mindset. This probably would also require some organizational changes, or
well, I don't know if I tell you. So you know, we're very concerned about the lack of women and the lack of diversity in artificial intelligence, particularly I mean, I want to get women like you do into coding and doing the jobs that the boys do, but I want to encourage diversity across the board in the whole field of AI. And you know, we knew when we did the AI review in 2017 that we were developing PhD programs and fellowship programs and master's programs that would be mainly about AI, but they would be fed by students who'd done maths and computing. So they were going to be not very diverse range of students doing this, and that has proved to be the case. So what we also put in the report was the encouraging the government to fund some master's AI courses that are aimed at non-technical students. So for students who came from any background, arts, humanities, drama, if you know, and we were asking the university to design courses to help them move into AI type jobs that would use AI or develop AI systems. And when the scheme was rolled out to encourage diversity, the government guidelines for the scheme were that they funded some scholarships, but if the university were to get those scholarships to give to students, 50% of those scholarships had to go to underrepresented groups. And that has been incredibly successful. It's beginning to get more diversity into, and it's tiny steps at the moment, but I really want to see that program rolled out more so that we encourage students who haven't started out in science or thinking about computing or AI, get the opportunity to move mid-career or early career, but get the opportunity to move sideways, so to speak.
Mm-hmm. Yeah, I think that's a very interesting approach, because it also will hopefully contribute towards more interdisciplinary work if people with different background come there. But it's also quite challenging, because if I come back to the discussion that we had before, you mentioned that designing AI algorithms and systems requires a lot of expertise. So if you're not...
Well, no, actually, it needs knowledge and expertise of what AI is and what you're trying to design, but it doesn't require you to be an extreme coder.
Okay, yeah. So
right? You can have a diverse team.
You need to be a good driver, but you don't necessarily need to be a good
mechanic. Yeah, exactly. And it's teamwork, isn't it?
That's true. Yeah, yeah. I think teamwork is number 6 in our list now. Ability to work in teams. We can see it.
And this is interesting because I mean, a lot of the very famous scientists don't have the ability. You know, they're very single-minded people, particularly from the. I don't think it's so true today. I think most of the people who win a Nobel Prize today have been running and been in a big team. In the early sort of 100 years ago in science, a lot of people worked on their own very much.
Yes, yes.
But I think that's changing.
I think I fully agree. This picture of science is changing. I mean, at the moment, we are also pretty much isolated, but for different reasons. And we are so much looking forward to come back to physical teams. Yeah. So there is one more topic that I would like to briefly address at the end of our conversation. And maybe we can move on now to the last tab that we have here. Oops, this is the previous slide, please. Okay. Yes, I would like to share with you this picture that I really love it. We are all tired of virtual meetings, but I think it was an interesting experience because many of us starting to think about now new ways of interacting in the scientific community. And I think this is the last item that I would like to discuss. We had a brief discussion on that already yesterday when I was having my Ask the President session. And I also want to be egoistic and get some inspiration from this discussion. So if we can move on now to the next slide, I would kindly ask you again to give a vote, or actually it's a multiple choice vote. You can choose now various formats of interaction for the future. If we can move on to the next slide, I think we will be able to move. Okay, yes, here it is. So you see that there are various ways on why and how you would like to interact with the community. It could be to promote your own research, to learn from others, etc. So again, you will find various options. You can choose as many of them as you would agree to. And in the meantime, I would like to ask you, Wendy, what would be your preferred way to interact with the community in the future? What kind of mixture of techniques and tools would you like to have? I mean, I know you like to travel, so I'm sure that you miss the physical interactions.
I do. I love to travel, but I also love this sort of thing. I was, in a way, I was made for this world. You know, I couldn't have done this. You only asked me, what, a month ago to do this? I couldn't have fitted this in if I'd had to fly somewhere to do this. right? I just wouldn't have got, you got an hour in my diary and I'm doing a lot. And I mean, of course, we're all suffering from overload because, of course, because you're not going anywhere, you just say yes to more Zoom meetings, and it's physically and mentally very tiring and not good for us. But I do think it's certainly reminded me about the balance of, I can do this, I can I can interact with the community in this way. And I find it very fulfilling. It's because, you know, I was at the stage where when I went to a conference, because of who I am and the fact that I tend to get flown in to do a keynote, I hardly ever mix with the ordinary people at the conference, if you know what I mean. I would go in and do what I always said I wouldn't do, give my keynote and leave. And leaving could be going to meet with government officials or having a dinner, or, you know, or just flying home. But I very rarely in the last few years have attended a conference properly, except the ones I've been organizing. And, you know, and that's silly in terms of the, you know, the cost of doing that in terms of the planet and my own physical health and mental health, but also just at the time, and it's rude to people as well, I think. So, and the trouble is, when you do this, I'm not meeting anyone at the conference, nor are you today, and so you don't get to meet the people who are listening to us. I love the way you've got the interaction going. So I do miss that, because what I hate most of all in COVID times is giving an hour-long keynote with PowerPoints to an audience I can't see. I just loathe that. And I don't know what the audience get out of it, but I get nothing out of it. So I much prefer this type of interaction, and I love the way you've got the audience involved as well. And I mean, in some sessions we get audiences to ask questions, and we do it that way, even though we don't meet. And I'm really enjoying it. But I'm a conference organizer too. I'm doing the website. I'm on the I chair the steering group for both the Web Science conferences and the big World Wide Web conferences, the web conferences. And I don't know what conferences are going to be like in the future. We've learned we can do this, but we also know we like the social interaction, and some of us like and can afford the traveling. I don't know what a hybrid conference is going to be like. I don't know what the new normal is going to be, because when we are running, you know, we ran the web conference and the Web Science conference, both of them went totally online this year, obviously, because of COVID. It meant many more people could attend. Right, the conference fees went down, people didn't have to travel, stay in hotels. The attendance went right up. Now, I don't know what the satisfaction quotient was, and you can do lots more things. You know, you don't have to pay to fly a keynote in, so you can do more sessions like this. You could have exciting panel sessions. You know, you appeared at the beginning of our conference, and for the, you know, the same with the big web conference, and you don't have to worry about booking hotels and conference venues and things. But when we emerge from this, next year is going to be, I think most things will be online next year because it's too uncertain. But by 2022, we'll be looking at what is a hybrid conference? And I think that could be the worst of all worlds in some ways, because you have some people who are there physically interacting and some people just coming in on whatever and won't have the same experience as the people who are there. And then you've got the problems of equality, because, you know, the people who can afford to go to conferences are the people that have travel budgets. And, you know, I think it's going to take a while in our world to settle down and to work out what is the new normal. What have we learned? What do we like? What do we hate giving up, and how does that all come together? I think for conference organizers who have got to think about budgets and whether they need to reserve hotel rooms and whether they've got to book a conference venue, who of course all be wanting business back, I think it's going to be quite a complicated equation.
Mm-hmm. Yes, I agree. It will be complicated, but I think there are also opportunities, because we really can think about new formats. And as you said, it's easier to bring in keynotes from all over the world.
Really exciting panels. And
yeah. And maybe we even have to abandon the concept of having a conference at 3 days in one specific week of the year. Maybe it would be rather an ongoing event. Let's say we meet every first Monday of the month to discuss and things like that. And there could be multiple ways. So
well, you're president of a society
Yes,
you're at the forefront of this, of a society that does a lot of this stuff. So you will be overseeing a number of experiments in this world. And some of them, you run some very big conferences.
Yes.
So.
I mean, we have not discussed this at all. There would be how to replace, for example, exhibitions, right?
Yeah.
So it's very difficult to
do. I think for a conference like this, which is relatively small, and web science is the same, you can. I think they'll just stay online, to be honest. You might have a regional get together, but I think the big conferences that ACM run, like SIGCHI and SIGGRAPH, and I don't know how they're going to play out. Yeah.
But you see, even for the small ones, people want to travel, so we need to offer them something as well.
They do, but you know that the conference attendance has gone down because people can't afford to travel, and
it's not only affordance; it's also environmental considerations. I mean,
exactly,
lots of CO2.
And I think the days of PhD students flying around the world to give stand by a poster at a conference halfway around the world are over.
Yeah. Which I would say
justify it.
Yeah. Okay, I think we are coming to the end of this conversation. I would like to thank you very much, Wendy. I hope it was not tiring. I hope it was a little bit inspiring to you. I enjoyed it very much that we had 1 hour to talk to each other. I'd like to thank the audience very much, and stay healthy. And I do know that you always wear masks, Wendy, so I brought mine.
Oh, I haven't got mine with me. I haven't got mine with me, but it's on my Twitter. I don't need it in the Caribbean anyway.
Okay, then enjoy the Caribbean sun. For all the others, enjoy.
It was lovely. Thank you so much for doing this. You've done it in a very entertaining way, and it's been lovely talking to you. Yeah, a really good hour together. Thank you.
Okay, wonderful. The conversations are still open, so if you want to do one or the other vote, you can still do this, and we will put the results later on the website. Thank you very much.
Okay.
Goodbye.
Bye for now. Bye, everybody.